Hi everyone. How many turning points can a polynomial graph have? Let's take n equals 1 as a degree, first degree, n equals 2, second degree, and n equals 3, third degree. So how many turning points can a first degree polynomial graph have? A first degree polynomial means linear. How many turning points can a line have? Well, none. The graph can never turn around. 0 turning points, TPs. How do you graph a second degree polynomial? That's going to be a parabola. And how many turning points does it have? It has to have exactly 1 at the vertex. So we're going to have 1 turning point here. But now how many turning points can a third degree polynomial graph have? It depends. And in fact, we have a couple of examples here. The graph of y equals 4x cubed, that has no turning points. We say that this function is monotonically increasing. It keeps going up, 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 up. This graph has no turning points, 0 turning points. But its partner over here, which is the graph we cared about earlier, this blue graph, it has 2 turning points. It has a local or relative maximum point, a hilltop point over here, and it has a local or relative minimum point, a valley bottom point over here. The red graph has 0 turning points. The blue graph has 2 turning points. So it depends. A third degree polynomial graph could have 0 or 2 turning points. It depends. Now, in general, only very high degree polynomial graphs can have many turning points. Only high degree polynomial functions can have very wavy graphs. In particular, the graph for a non-constant nth degree polynomial, y equals f of x, can have no more than n minus 1 turning points. So for example, if you have a polynomial graph with 99 turning points, then that means that the degree better be 100 or higher. Only high degree polynomial graphs can be very wavy and have many turning points. Now let's say we have an even degree polynomial graph. And it does matter very much if the degree is even versus odd. In the long run, what does a non-constant even degree polynomial graph look like in the long run? It has to look like a bowl. In the long run, now it might be a little wavy in the middle, but in the long run, you're going to get a bowl, which means that ultimately you have to go back to where you came from. If you came down from heaven, you have to go back up to heaven. Which means that you have to have an odd number of turning points. The graph of a non-constant even degree polynomial must have an odd number of TPs. Because a bowl can turn around once, and then all future turning points have to come in pairs. If you turn around again, it has to turn around again. And then if it turns around again, it has to turn around again. So after the first turning point, all subsequent turning points have to come in pairs. So odd number of turning points. Could be 1, could be 3, could be 5, and so forth, depending on the degree.